Hi there. All right, you're welcome again. Now take a look at this image. Take a very good look at it. What do you think that is? A ruler, right? Well, hold on shortly and you will know whether this image is a ruler or not. I'll be right back. Now, this image is not a ruler. Okay? This is not a ruler. In fact, this is actually called a slide rule. It is not your normal conventional ruler or the normal conventional ruler that you are accustomed to. This is a slide rule. Now, this particular slide rule, as you can see beside me, was used majorly around I think it was invented in England shortly after John Napier. Remember in the last video, I spoke about the Napier's bone, which was actually the invention of John Napier. And Napier was credited for the creation of the logarithm table. Okay, so it was from the logarithm table it got the Napier's bone, where it could get the logarithm of each operand and then perform addition on these numbers to get multiplication. That is, you can do multiplication by adding numbers. Now you fast forward, and then the slide rule was invented in England. I think it is around 1932 or so. Okay, and it was so popular then that even up to 1960, the slide rule was still used by NASA. No, NASA, right? That's the meaning of the acronym NASA. Okay, NASA there, NASA. All right, so NASA was still making use of the slide rule, during its Apollo program, that program that landed the first, man on the moon. Majority of the calculations that was done by scientists, engineers, they made use of this slide rule. That is to tell you how, important the slide rule was back then. All right, so now what is the slide rule? Remember, we're still on the history of computing. Okay, the slide rule is actually, as you can see from the image, it looks like a ruler, right? So what it actually does is that it performs mathematical calculation. You can think of addition, subtraction, multiplication, division, and I think it could also even perform square root or even square. Okay, so it just works simply based on the fact that the slide rule does not have the conventional scales that your normal ruler have. It has logarithm scales. Okay, logarithm. So that logarithm scales that the slide rule has, what happens is that when you want to make any calculations using the slide rule, you have an upper scale, a lower scale, and then you have the slide whereby you can be able to slide in and out to any number that you're trying to add, because usually it's logarithm scales. So you do addition to get multiplication, and then you do subtraction to get division. So what happens is that when you want to do your addition, you slide through, okay, so that you can be able to add, and subtract numbers to perform multiplication or divisions. And of course, like I said, you can also do square roots or squares. Okay, so now Briefly, I'm going to talk about logarithm because the slide rule uses the logarithm scale. And I know a lot of person will be saying, what is logarithm? What is logarithm? I'm sure whilst you were in secondary school when you did mathematics, for majority of you who did mathematics, in JSS, I think from JSS 3, SS1 if you are still in SS, or if you are still in JSS, SS2, SS3, or you have even done with secondary school or you're in the university, you must have made use of this. Okay, back here in Nigeria, we call it the four-figure table. Okay, inside of this booklet, which sometimes you they take, to WAEC examination, inside of this contains the logarithm table. Okay, so logarithm was a very, interesting invention back then when you're talking about mathematical calculation because it simplified a lot of things. So now I'm going to, give a little lecture, you know, on logarithm. I'm going to be making use of the board right here behind me. I'll be back shortly. All right. Now, remember I said I'm going to be making use of this board, you know, to give a little bit explanation of what logarithm is all about. Okay. Now, the slide rule actually use logarithm scales, as I said. And for those of us in Nigeria that made use of the four-figure table, um, I showed you the image, and this is just the image again, as you can see. That is the four-figure table. Inside of this, you see the logarithms, and stuff like that. So now, what is logarithm? Okay. Now, the logarithm of a number is the power that another number will be raised to give you that number that you are looking for the logarithm. That sounds confusing, right? That's the reason why I'm using this board. Now, take a look at this. If, for instance, you are told to look for the logarithm of 27, okay, and then you get your answer as theory. This theory is the logarithm of 27, right? So what does this theory mean? Okay, so I said that the logarithm of a number is the power. So this theory is a power, right? This is a power. You can call it the exponent, okay? Because when you say 2, normally in English terms, we call it 2 raised to the power of, 3 and stuff like that. So it's the exponent of 2, the power of 2. Okay, now, so this theory is the power that another number needs to be raised to give you this 27 that you are looking for the logarithm of. So that's exactly what I mean by what I defined a while ago. Now, what is that number, okay, that needs to be raised to this power of 3? That number is actually the base, okay? So, in this case scenario, that means the base is 3, okay? So, if 3 is raised to the power of 3, you are going to get what? 27. That is 3 times 3 times 3. Okay? 3 times 3 is what? 9. Times 3, what will you get? You'll get what? 27. Okay? So, remember I said that logarithms, before the coming of the electronic calculator, it made mathematical calculation easier because remember now we have calculators. So anything you want to do, you want to perform multiplication, addition of large numbers and stuff, you just punch your calculator. But back then it wasn't so. There was no electronic calculator in 1932 when the slide rule was invented. Okay, so what you had was the logarithm. Okay, the logarithm table. So Napier took advantage of that to bring about the Napier's bone, and then the slide rule was invented, and they also made use of the logarithm. So that's the reason why I'm just giving you, a simple mathematical explanation of logarithm. Okay, I know some of you really do not like math a lot, but it's interesting. So you just pay attention. From what I've just explained just now, you can see what logarithm is. Okay. Now, remember I said that there is a base now, right? And in this case, you see that the base is 3. Now, based on this, we have like two types of logarithms. Okay. Based on this base, we have two major types. Rather, we have the common logarithm. This one is common logarithm. In this common logarithm, most of the numbers is in base 10. Okay, so let's say you are looking for log 100. The common logarithm of let's say 1000, the common logarithm of 1000 will be 2, or rather 3, sorry. So why did I say the common logarithm of 1000 is 3? Because remember I said that in common logarithm you have a base of 10. Okay, you have a base of what? 10 in common logarithm, meaning that 10 times 10 times 10 will give you what? 1000. So this is 10. Okay, so this is the common logarithm of what? Of 1000. So now imagine you have 1 million and say the logarithm of 1 million. How many zeros are in 1 million? 6, right? So the logarithm of the common logarithm of 1 million will be what? 6. You can see that those large numbers, they have actually been what? Compressed to something that you can easily calculate. Okay, you see the reason why logarithm, was very popular, before the coming of the electronic calculator. And many of you who did logarithm in mathematics in school, you didn't even know the reason why you were doing it. Okay, all right. So now that is common logarithm. Okay, remember common logarithm is to the what? To the base 10. Now we also have another logarithm that is called the natural logarithm. The natural logarithm. Now the natural logarithm is to the base is normally written as ln or log e. In scientific calculator, you will see this. You won't see this, or maybe some of them could write this. I'm talking about electronic scientific calculator. You will see ln. Now, ln is the natural logarithm of any number, and the natural logarithm is that e that you are seeing there actually stands for Euler's constant. Euler's constant, and Euler's constant is 2.71828. Okay, so that is Euler's constant. Okay, now when we say the natural logarithm, let's say the natural logarithm of 75, let's say the natural logarithm of 75 is 4. When we say the natural logarithm of 75 is 4, what we mean is that 2.7, let me to 3 decimal places, 718 raised to the power of 4, you are going to get 75. That is exactly what this means. Okay, can you see now? Okay, how logarithm, simplify a lot of large numbers, in order for you to what? To calculate it. Now, let's go to some logarithm rules. Okay, because you also have what is called logarithm rules, because in the invention of logarithm that is being used to calculate, they also have rules. Remember I said that with logarithm you can actually do addition, you know while you want to multiply numbers rather than multiply what you add. So let me give you that shortly. Let's say you want to add, or you want to multiply 2 times 3. Okay, something as basic as that. Okay, so if you are using logarithm, you can say log 2 plus log 3. Now, under logarithm law, when you have two numbers added like this, what you are going to have is log 2 times 3. Okay, and you are going to get log 6. So this is the answer to this. Okay, so if this is a natural logarithm, okay, if it's natural logarithm, it means that the log 10 6. Okay, so what does this log 10 6 means? It means that actually um you look for the logarithm, that is the logarithm of 6. That's exactly what is saying. The logarithm, that is log 2 plus log 3, will give you log 2 times 3. Okay, that is exactly what? Log 6. Okay, now if you want to do if you want to do subtraction, let's say 6 divided by 3, that will be log 6 minus log 3. Okay, when you do that, you are going to have, all right. So like I was saying, when you subtract this number, log 6 minus log 3, you are going to get what? Log 6 over 3. Okay, so this is the addition rule and this is the subtraction rule. So this is like the two major rules, that the slide rule uses when it wants to perform multiplication by adding numbers. Okay, so you can see why the slide rule was, a very important tool back then. Okay, because of these rules of logarithm. Okay, so meaning that you can have something like log 636, and you can guess the answer. Okay, the answer will be actually 2. Why? Because 6 raised to the power of 2 will give you what? 36. Now from this you can see that this is actually the reverse of this. Okay, the reverse of this is this, and this is normally called the what you call anti-log. Anti-log in mathematics. It's normally called the anti-log. So for instance, we have something like log 10 1000, okay, as theory. Okay, so when you have log 10 1000, it means that 10 raised to the power of 3 will give you what? 1000. This is the anti-log. Okay, so it is from this principle, because in the slide rule you already have these anti-logs in the scale. Okay, so when you slide a particular number, let's say we did addition. Now let's say, okay, let's say this 1000 for instance. Now, okay, we have, remember this log 1000 is 3, so you already have 3 in the scale. Okay, instead of having 1000, you have something like 3. okay, and you have something like 2. When you add the two of them together, you have something like 6. 3 plus 3, okay, you have 6, okay. So from that, you will see that the anti-log of this will actually give you what? The final answer. So that's the reason why in the slide rule, they just slide the rule. You can have 2 at the middle where they are sliding it, and then before you know it, it gets to, let's say, 3, for instance. And when it gets to 3, you look at the other side, you see where the number is touching, and you get the anti-log as your what? As your result. So that is exactly how the slide rule works. Okay, so now take a look. All right, so like I was saying, when you subtract this number, log 6 minus log 3, you are going to get what? Log 6 over 3. Okay, so this is the addition rule and this is the subtraction rule. So this is like the two major rules, that the slide rule uses when it wants to perform multiplication by adding numbers. Okay, so you can see why the slide rule was, a very important tool back then. Okay, because of these rules of logarithm. Okay, so meaning that you can have something like log 6 36, and you can guess the answer. Okay, the answer will be actually 2. Why? Because 6 raised to the power of 2 will give you what? 36. Now from this you can see that this is actually the reverse of this. Okay, the reverse of this is this, and this is normally called the what you call anti-log. Anti-log in mathematics. It's normally called the anti-log. So for instance, we have something like log 10 1000, okay, as theory. Okay, so when you have log 10 1000, it means that 10 raised to the power of 3 will give you what? 1000. This is the anti-log. Okay, so it is from this principle, because in the slide rule you already have these anti-logs in the scale. Okay, so when you slide a particular number, let's say we did addition. Now let's say this 1000, for instance. Now, okay, we have, remember this log 1000 is 3, so you already have 3 in the scale. Okay, instead of having 1000, you have something like 3. Okay, and you have something like 2. When you add the two of them together, you have something like 6. 3 plus 3, okay, you have 6. Okay, so from that you will see that the anti-log of this will actually give you what? The final answer. So that's the reason why in the slide rule, they just slide the rule. You can have 2 at the middle where they are sliding it, and then before you know it, it gets to, let's say, 3, for instance. And when it gets to 3, you look at the other side, you see where the number is touching, and you get the anti-log as your what? As your result. So that is exactly how the slide rule works. Okay, so now take a look at this video. I'll be right back shortly. All right, so that is the slide rule for you. Okay, so you can see the slide rule is a very important device that was used, for mathematical calculation around 1932, the period of 1932 to 1960, before you have, in I think in 1973 or 1974 or so, or something, before you now had, the first electronic calculators. Okay, so it uses or works using the principle of, the logarithm, because it has logarithm scales, and As you can see, I just explained a little bit, because logarithm is deep, but I just gave you a surface, a scratch of what logarithm is all about. All right, so that is for the slide rule. Okay, the slide rule, mind you, is still being used today. Okay, still being used, but of course, I don't really think many of our students will be taking using the slide rule when you have the electronic calculator. Okay, calculator has made everything very simple. You just punch it, and you get your answer. Okay, so you can look at the slide rule like a mechanical calculator. Now, talking about mechanical calculator, um, a German professor, which leads us to the next device that we're going to talk about. The first gear driven calculating device was invented by William Schickard. Schickard, is it Schickard? Schickard. That's a German name, but that's the spelling right there beside me, William Schickard. Okay. Now, William Schickard actually invented the first gear driven calculating clock. So take note of that one. So when we're talking about gear, just look at this picture now, gear, right? Gear actually, tries to change the acceleration or the movement of certain things, through different levels using a gear mechanism. Okay, so that's a picture or the image of how a gear looks like. So if you look at the device, now take a look at the device. The device is looking like a clock, right? Okay, so that's why it's called William Schickard's calculating clock. Okay, now I think it was invented around 1617 or so, around them by, and this man William Schickard is actually a German professor. Okay, a German professor, and funny enough, this invention actually got publicity after his death in the bubonic plague. You know, and the bubonic plague is like you have a disease outbreak now, right? Like the Ebola, the coronavirus and stuff, So William Schickard actually died as a result of the bubonic plague that happened at that particular time. So after he died, his invention, the calculating clock, became popular, okay, and widespread. All right, so that is for William Schickard. Okay. Now in the next video, I'm going to be talking about Hermann Hollerith Punchcard and then Charles Babbage. I talked about talking about Charles Babbage, but I realized I need to talk about Hermann Hollerith Punchcard before talking about Charles Babbage. So in the next video, I'm going to be talking about Hermann Hollerith punch card, and then of course what many people widely regard as the father of computers, Charles Babbage. So watch out for my next video. Bye.